All right, let's take a look at this fourth set of notes here. Last time around, we were working with quantitative data and we were looking at pictures like graphs and histograms and things like that. This time, we're going to look at quantitative data, but we're going to do it in numbers. All right, so um, we've been talking about these things of like shape, center, variation, and outliers. Okay, shape is something like is best described with a picture. But you can get a little bit more specific about center. And we tend to measure the center of a set of data in two ways. One is using the mean, okay, which is like you add up all the values and divide by that number. The other one is the median, which is the midpoint of the distribution. So 50% of the data points are below, 50% of the data points are above. Now, if the data set has an odd number, that's pretty easy. The median is the number exactly in the middle. Um, if the data set has even number of values, then you look at the two data points that are in the middle and you average those, right? So you just take those and you find the point halfway between those. That'll put 50% on both sides. Now, as far as a measure of center, the median is probably better than the mean for just giving a measure of center. It's because it's what's called resistant. So if you take an extreme value, excuse me, and you like take one of the data points, let's say at the end, and you make it really, really, really big, the median is not going to move. The mean will slide right with that thing. So the mean is going to move, but the median will not. So the median is more resistant. It's not as sensitive to extreme values as the mean is. However, we're going to find out later on in this course, when you go to do calculations and inferences, the mean's your guy. Okay, it's really, really complicated to do calculations and inferences using a median. It is done. Modern day, we do this with computers all the time, but generally speaking, most inferential statistics does it with the mean because it's easier math to do it. Okay, so there's a relationship with skew here. If your data set is skewed left, which means the tail goes to the left, which means you have an extreme value going to the left, then the mean is going to be less than the median. It's going to be to the left of the median. Likewise, if your data set is skewed right, you have an extreme value going to the right, the mean's going to go above the median, right? It's going to be to the right of the median in the data set. If your data set is symmetric, chances are the mean and the median are going to be the same value or really close to each other. Okay? So this affects skewness. So it does affect the shape, right? The relationship of the mean and the median affects the shape of the data set. There you go. All right. I'm going to pause for a second. Oh, there we go. Had to wait for the internet to catch up with me there. We're going to take a brief pause here and do this thing on relative positions. Quartiles are like fences that divide your data set into four groups, 25% of the data in each of the groups. So the first quartile is between 25 and 75% of the data. There is no second quartile because we have a fancy name for that. We call it the median because it's 50% on both sides. The third quartile has 75 below it, 25% above it. Basically, the median is the second quartile. The first quartile is the median of the numbers below the median. So it's like the median of the lower part of the median, the numbers below the median. The third quartile is the median of the data values that are above the median. Okay, so then you're going to get 25, 25, 25, 25. The middle 50% are between the first and the third quartile. We're going to put a pin there. We're going to come back to this quartile stuff in a second, but just be aware that this exists. Okay, so measuring variability. The cheapest and easiest way to measure variability is to take the left side of the data set, the low end, the high side of the data set, the high end, and just find the distance between them. Maximum minus minimum gets you the range of the data set. Not really useful, but it gives you an idea of how far apart the data points are, right? We're going to find that the one that we tend to use is this thing called the standard deviation. It's got a funky formula here. We're going to do some deep dives into why that formula works and all of this. But generally speaking, this gives you the average distance that a value will be from the mean. Well, a typical distance. Average is a weird word there. A typical distance that a value will be from the mean. So you get this by like, if you look at the formula, it's kind of weird. You're taking the distance from the mean of a whole bunch of numbers. So the x1 is there. That should be an x bar. I will fix that on your notes when you see it. It'll be an x bar. Actually, here, let me pause this and I'll fix it right now. So there you go, the wonder of the internet. Now they all have bars, right? So it's the value minus the mean squared, and then you add those up. All the values minus the mean squared. You divide that by the number of values minus 1. That seems like a really weird thing to do, and we'll talk about that a little bit later on in the course as to why it's n minus 1. And then you take the square root of the whole thing. That is the standard deviation of a sample, okay? So that's a number that gives you the typical distance the values are from the mean. It's a little bit of a complicated thing, but generally speaking, if you have to calculate the standard deviation in this course, you're probably going to do it using the calculator. So we'll kind of go there, and that's like built in as one of your calculator functions. So another measure of variability is the interquartile range, okay? So back here, we found quartile 1, quartile 2, these things that broke things into 25, 50, 50, so 75 and 100%, right? So the quartile 1 is between the lowest 25 and the top 75. Quartile 3 is between the lowest 75 and the top 25. One way to talk about how far apart things are in your data set is how far apart are those two numbers, which is what we call the IQR, the interquartile range. So the middle 50%, how far apart are they? So you take Q3, you subtract Q1, you get the IQR. This also gives us a way to define outliers. The technical definition of an outlier is that it is a data point that is 1.5 times the IQR above the third quartile, so that would be a high level outlier way up at the top, or 1.5 times the IQR below the first quartile. So that's going to be like an extreme low value. If you have one of those things, that's an outlier. It's a point that's away from the data set that you got to do some thinking about, and like, why is this point so far away from everything else? And usually you can come up with a pretty good, decent story as to why that is. So one of the ways that we summarize data is using a 5-number summary. It gives you the minimum, which is the lowest value in the data set, the first quartile, which breaks you into 25% of the data is below it, 75% is above it, the median, which breaks the data into 50-50, the third quartile, where you have 75% of the data is below it, and 25% is above it, and then the maximum, where that's the top point where all the data is below that. So this will give you a 5 numbers that you can take, 5 numbers to describe the data set in a pretty useful way. People in statistics have developed this thing, which is a visual representation of a 5-number summary. So in this data set, the duration of whatever we're measuring is going to have a minimum value of 1.5 minutes. The data set's highest value is 5 minutes. The median is right here, so that's that bar in the middle, is 4 minutes. The first quartile is 2 minutes, and the third quartile is around 4.5, maybe 4.4 minutes, right? So this means that 25% of the data is here, 25% is in the beginning part of the bar, 25% is at the end part of the bar, and 25% is from the bar to the end of the tail. So this is like a pictorial representation of the 5-number summary. Minimum, first quartile, median, third quartile, maximum. Now, it is possible to give numeric measurements to describe a distribution. This is what we're talking about here. So if I say describe a distribution, you're now like a little bit more on the hook, right? Like when we say, oh, you could give the mean and the median when we talk about measures of center. If we talk about measures of variation, you can give the range, the standard deviation, or the interquartile range, and you could talk about its measures of variation. If you want to talk about the set as a whole, like how is it distributed, you can use the minimum, the first quartile, the median, the third quartile, or the maximum. It's the 5-number summary. And if you want to represent that 5-number summary graphically, you would create a box plot. All right, so this is a quick overview of describing quantitative data with numbers. We're going to do some playing around with this in the next class, and we'll see you soon. Have a great day.